Hello, everyone. My name is Saedi Nia. I'm a post-bachelor's intern here at Oak Ridge National Lab under the Computational Sciences and Engineering Division. And yes, today I'll be talking about an agentic approach to CMIP data discovery using large language models. And before I begin, I just wanted to thank my contributors and collaborators listed here for both enabling and assisting on this project. Before diving in, I wanted to start with some background on the Earth System Grid Federation, or ESGF. It's an international consortium and global network of data centers that archive and distribute Earth system data in the form of model outputs and observational data. And among these data, are CMIP data sets. And so the data distributed by ESGF is a crucial resource for Earth system research around the world. Then it follows that ensuring that this data is accessible to users is sort of a critical focus of this project. And there are existing methods like Intake ESGF, which is a sort of programmatic way to access ESGF holdings, and Metagrid, which is a web interface for the same purpose. While these tools are fairly powerful, they do require some technical expertise like programming knowledge or some metadata understanding. And because we have a sort of broad user base with a broad range of skill sets from sort of domain experts to less technical users, we set out to determine whether or not we could use the power of these large language models, or LLMs, to build an intuitive natural language bridge to sort of bridge the gap between users and the data held within ESGF. And so our research led us to building what's called a domain-specific LLM. So we wanted a domain-specific LLM as opposed to a general-purpose model like ChatGPT, because while these general-purpose models do offer a broad utility, they do tend to falter when it comes to more specialized tasks in the fields. So they would maybe produce incomplete or hallucinated responses when you ask for something more specific, let's say specifically related to ESGF. So where a domain-specific LLM could shine in that case, where it could be trained on a custom curated data set of our choosing, it could understand domain-relevant terms and meanings, and could be adapted to a specific task, like generating code, for instance. So initially, to accomplish this, we went with a fine-tuning approach, which is just the process of taking a pre-trained general model and then retraining it on a task-specific data set to improve its performance on that specific domain. And so this is what the process looked like within our system. We would take Meta's Llama 3.1 open source model, specifically the 8 billion parameter model, and we'd fine tune it using an ESGF specific data set. And so this data set consisted of thousands of rows of instruction output pairs geared primarily towards code generation. So a row would consist of sort of a user's request for a runnable Python script to grab data from ESGF with sort of these specified facets. And then the model response would then be accurate code, so the user could then take that code, run it, and download those data sets. And this was deployed through Ollama as an inference engine and a sort of intuitive web interface called Open Web UI. And in practice, what it ended up looking like is something like this, where the user could ask something like, I need code to download datasets that contain precipitation and GPP for the Canyon SM5 model under SSP 245 using Intake ESGF. And the model would then output something like this with a nice message in response, and then give you runnable code that you could then copy, paste into your terminal, download those datasets, and then perform the analysis you want. And if you are interested in more details about this fine-tuning process, I do encourage you to please check out the paper we put out on this subject last year, published at the IEEE conference. But as the AI field has evolved, we begin to encounter some limitations with fine-tuning alone. So we ran into these limits where when you're just fine-tuning, it's not easily extensible, meaning to add new functionality, you require a lot more training data, either data collection or data generation. When you do train the model for these specialized tasks, you can start to overwrite the model's general capabilities and general reasoning. And also the model's knowledge, or the knowledge you've given it with the fine tuning, is sort of frozen at that training time. So to add more knowledge or vocabularies, you would have to retrain the model or go through more fine tuning cycles. So ultimately, the thing we would like is sort of this reasoning power of a general purpose LLM paired with sort of authoritative domain specific grounding to make sure those outputs are correct. And it's not just relying on the general model's knowledge alone. And so this led us to experiment with an agentic approach, by which we mean an AI system that uses LLMs to sort of reason, plan, autonomously invoke external tools, just to answer these natural language queries rather than relying on that embedded knowledge of the model alone. And so the benefits of this for us specifically are that we can then maintain the general reasoning capability of that model, while also grounding the response in agentic tools and the outputs of those tools, instead of just relying on what the model happens to remember. The agent is then modular and extensible, meaning we could add those capabilities as need arises fairly easily without needing to do additional training cycles. And also it supports multi-step reasoning for us, and this we could highlight later in a demo later on, but it can chain these tools together to sort of contextualize the outputs and then give it back to the user. And so the agentic system we developed works in sort of a loop where the user can submit a natural language query, and then the agent can determine what tools are necessary to call and in what order. And just to note, currently our model uses the Google's Gemma 4 model as the sort of driving LLM. But then you see when the tool outputs then go back to the agent LLM, and then the LLM can then decide whether the query is satisfied or could return that response back to the user, or if it needs to then call on those tools again. So you can see the tools here are a pretty integral part to the system as a whole. It's what we use to ensure correctness of the outputs. And so I thought it'd be helpful to go over some of the tools that we've developed for this. And to clarify, what we mean by tools are essentially just functions exposed to the agent. So the LLM can then decide which ones to call, what arguments to pass, and how to interpret those results. So we have a couple tools just focused on semantically searching variable databases for CMIP 6 and CMIP 7, and also a sort of function to break down that newer scheme of CMIP 7 variables that we'll go into more detail on the next slide. A sort of function to admit output runnable intake ESGF Python code, sort of how we had the fine-tune model running, and also just a helper function to map canonical terms or facets to their terms in ESGF. So something like monthly be translated to mon. Again, I wanted to highlight the tools we have to address CMIP 7 metadata specifically. So CMIP 7 introduces this brand new name scheme for variables that now sort of encode the metadata directly into the name in the form displayed here, where you can see it has a variable root and then different labels. So temporal label, vertical, horizontal label, aerial label. So all this metadata baked into the variable name itself. So we thought it helpful for users if they could sort of ask the agent first to find the variables in CMIP 7 through a semantic search, through some keyword or something related. And then also have the agent to be able to break that down, or break those variables down rather, into its core components. And then that, alongside with the other tools we have, would make it pretty easy to then go back and forth between CMIP 6 and CMIP 7 and vice versa, just to cross-reference those. And so I'm going to show a short demo to showcase the agent in practice. I want to note that I'm showcasing a sort of dev environment interface, mostly because how it shows the agentic thought process and sort of explicit tool calling that's happening under the hood. Did you see it when I make it bigger like this?
Yeah, I can see it. Daniel, it's just a bit dark. That's all. Because of the background.
Yeah, I will. Yeah, apologies. I'll post a link to this video also in the chat after this, in case this isn't very legible.
Yeah, that'd be great. Thank you.
So we start by sort of asking a simplistic question of, hello, I'd like some information about variables. And you can see sort of the thought process of the agent, and then it's sort of asking for clarifying questions of what variables are you interested in, and specifically what CMIP version are you interested in. So currently supporting CMIP 6 or 7. So we ask about what you have on precipitation for CMIP 7, for example. And so you could see it calling that find variable CMIP 7 function, getting its output, and then using the output of those tools to then present in plain language some variables that's found through our databases specific to CMIP 7 about precipitation. And so, again, we thought it helpful because this is sort of a newer naming scheme, that for users, if they could ask, let's say, I'm unfamiliar with branded variables, can you break down the variable or this first variable for us and see what it outputs? And so you could see after that query, the agent goes through a thought process, calls the correct tool to explain that branded variable, and we have a sort of output where we have the root name of that branded variable and all the labels associated with it, and sort of in plain language to explain what that means to a user. And so if we wanted to sort of find the equivalent variables in CMIP 6, we could ask something like, what are the variables for precipitation in CMIP 6? It'll call that tool specific for CMIP 6, and then using that tool output, list a few variable IDs that might be relevant to the user. And some context along with those variable IDs as well. And so we'd like to be able to just grab the information we got, and along with some other facets, and sort of generate a query to download data sets now from the SGF. So let's see, shortly. So we could submit something like, I want code to download data sets for variables PR and PRRA under historical and high emission scenarios. And then you can specify the models, like I would like them for CSM2 and KNESM5 at a daily frequency. And so here's where we can sort of showcase that multi-step reasoning that we talked about earlier, where you'll see it call the normalized ESGF facet function a couple times to sort of map those canonical values, and then eventually call that intake ESGF code to give you sort of a runnable code that you could then copy into a terminal and execute and download those data sets. Okay.
Daniel, you've got about 2 minutes left, roughly.
All right. So I just wanted to point out that this is still very much a work in progress. So we have several things we want to expand on with this new agentic approach. One, we wanted to work on sort of an interactive Jupyter Notebook environment or a Google Cloud Notebook where users could maybe run the agent with their own LLM APIs, extend the agent's toolkits with some things beyond discovery tools for data analysis and plotting. This is our sort of first foray into agentic tool development. So we did want to eventually expose these tools as an MCP server for other workflows to integrate, and then also integrate other MCP servers into our agent as well. And then I did want to try out leveraging the fine-tune model that we built initially, and then loop that back into the agent and see how that compares with for code generation rather than the method we have now. And so, yeah, that's all I have. This sort of contact information. I'm wrapping up my internship here at Oak Ridge National Lab, but I am an incoming PhD student at the University of Tennessee. Here's my contact info, and with whatever time is left, I'm happy to take questions.
Okay, thank you, Daniel. That was really interesting. Has anybody, I don't see any hands up. Has anyone got a question they want to ask? All right, Juliet, you've got a question?
Yes, hi. Thank you for your presentation. Really interesting tool. I was wondering what type of like validation had been done on the tool. Do you know how often it hallucinates or just like makes mistake? If you want to like send that to users that don't know a lot about CMIP, like can we trust it to like say the right thing?
So right now, it is early on, so a lot of the validation is done in-house with our many researchers we have working on the ESGF project. So we'll submit a bunch of prompts and see whether those outputs are correct. But these outputs are grounded in actual databases we created, and we try to make sure that the model does not then hallucinate a response and instead is only grounded in that information it has. But yeah, there are more testing needs to be done for sure to just ensure that it's not generating something you don't want.
Got another question from Ala Al-Kodaji. I don't know, is he there?
Hi, sorry, I was just activating my camera. Thanks, Daniel, for the talk. Appreciate it. Just along the same lines, obviously LLMs are stochastic in nature. How would you ensure that they behave in a deterministic-like way? Obviously, the answer should not change no matter how you ask the question, whether multiple times or in different ways, given the underlying data. Thank you.
Yeah, and so yes, the only variation you really want to see is sort of just variation in natural language itself. But the intention of these tools is to present that grounding. So sort of agnostic of what model you use, it shouldn't be relying on what that model has been trained on, but rather the output of these tools to sort of ground those responses. And so that is where the factual understanding and the part we can on is coming from. And then the LLM itself is just sort of as long as it's able to call these tools reliably and know when to call them, then that part of it is taken care of for us. So I don't necessarily trust the embedded information in the model itself until it runs through our tools and I know where it's getting the information from.
Okay, thanks, Daniel.